So it says, Marianne just returned from a visit with her grandchildren back east. The trip was 2,400 miles from her home, and her total time in the airplane for the round trip was 10 hours. If the plane was flying at a rate of 500 miles per hour, what was the speed of the jet stream? So the jet stream is an air current that is kind of high up in the atmosphere. We're not too high. It's where the same elevation that planes travel. And it's kind of like a steady stream of air, and airplanes can tend to take advantage of this. And sometimes if you fly in a plane, the pilot will mention that because we're in the jet stream, we might shave, half an hour off our trip or something like that. So even though the plane is exerting, 500 miles per hour with their engines, the jet stream can kind of push you a little bit faster. Although if you're going against the jet stream, it can slow you down. So this is what we're dealing with here. So I think what we want to do is keep in mind, by the way, you may need to read these problems like 3 or 4 or 5 times before you kind of get the sense of it. So don't feel bad if that's the case. That's totally normal. We want to try to, once we've got a kind of handle on it, we want to try to draw a picture of what's going on. If we can do that, that usually is helpful. So the trip is 2,400 miles. And it's we're doing a round trip here. Okay, so we're going from point A to point B, and that's 2,400 miles. All right, and there's a jet stream that's blowing one of the 2 directions. I don't know which way it's blowing, but there's this jet stream that's blowing at some speed, right? But we don't know the speed of that jet stream. Okay, let's say R equals the speed of the jet stream. They want us to find it. Usually if there's something they want you to find, that's what you want your variable to be. Almost always, that's what you should do. What was the speed of the jet stream? Let R be the speed of the jet stream. Why am I using the letter R? Well, R stands for rate. So the rate at which we move is the speed. Now the plane here is traveling at 500 miles per hour, right? So when we travel with the jet stream, we're going to be traveling at 500 miles per hour plus R. All right, so the speed with the jet stream is R plus 500. And when we're going against the jet stream, so the speed against the jet stream, we're going to take 500 miles per hour and subtract R. Okay. And then what else do we know here? We know the total time for the trip was 10 hours. Okay, so we've got distances, we've got speeds, and we've got times. How are all these things related? Well, you might recall that the distance traveled is equal to rate times time, right? If you're going 60 miles per hour and you travel for 1 hour, you go 60 miles. Or if you went 60 miles an hour for 2 hours, you traveled 60 times 2, 120 miles. Right? So you multiply rate times time to get distance. So that might come in handy. That's a relationship we might be able to use. So let's see here. The rate, so the total time for the whole trip was 10 hours. We don't know how much time she spent traveling in any one segment of the journey. So I can't say that it was 5 hours this way and 5 hours back, because actually if she's going faster in one direction, it'll actually be less than 10 hours. All we know is the total time. Let's see. Actually, what I do know is that the sum of those 2 times is 10 hours, though. So we can think about the time in one direction and then the time back. And we know that the sum of those 2 times is 10. So there's an equation we can look at. time 1 plus, oops, time 2 we know is 10. So there's an equation. So let's work with that. See if we can turn this into an equation that we can work with here. Time in one direction plus time in the other direction totaled to 10 hours, right? Okay. Well, I can express time in terms of distance and rate because I can solve this for time, right? So this equation, if we divide both sides by rate, the rates cancel on the right-hand side, and I see that time is the same as distance divided by rate, all right? So time 1 is the distance divided by the rate in that direction. Now the rate in that direction is, say that's the speed, that's the maybe where we're going with the jet stream in that direction. That's r plus 500, right? The time in the other direction, say it's when we're going against the jet stream, that's the same distance, right? But it's it's 500 minus r, because that's again distance divided by rate equals 10. Moreover, we know a little bit more. We know the distance, right? The distance is 2,400, and that's the same in both directions. So there's our equation. It's 2,400. Let me put these in the same, kind of write in the same way. Instead of writing r plus 500, I'm going to write 500 plus r plus 2,400, 500 minus r equals 10. Okay? So let's do this. Let's work out this equation now on another sheet. Okay. So that's what we have to solve, because we're looking for the rate. So if we just solve this for r, we'll have our answer. All right, well, I've got some fractions here. Whenever we have fractions, what do we want to do? We want to clear those denominators out. So I want to multiply by something that will cancel this and also cancel this. So why don't we just do the product of these two things? That's the least common denominator, or the least common multiple of the two denominators. Right? So I'm going to multiply both sides times the product of these two things. So we're going to do 500 plus r times 500 minus r. I'm going to multiply that times this stuff. And I'm going to multiply it by the other side too. Okay. Now, when I multiply, I distribute, right? So I'm going to have 500 plus r times 500 minus r times this guy. Then I'm going to have plus 500 plus r times 500 minus r times this guy. And then I've got equals. So that's just, now this guy, I think we can simplify this. This is a plus b times a minus b. That's a difference of squares, a squared minus b squared. Right? A plus b times a minus b is a squared minus b squared. So this is just 500 squared. So that's 25, oh, forgot the 10 there. Don't forget we have a 10 out front. 10 times 25,000 minus r squared. Right? That's what this can be written as. Now let's see what we can do with this stuff. Well, it's not so bad because these things cancel. These things cancel. All right. So let's see here. 2,400 times 500. Well, let's see. What's 24 times 5? It's 120. And then I've got 0, 0, 0, 0. So 120 with 4 zeros after it. when I multiply this times the 500. Right, so 120 with 1, 2, 3, 4 zeros after it. Minus, this also hits the R, so I got minus 2400 R. And then this thing, 2400 times 500, same thing. 120 plus 1, 2, 3, 4 zeros, plus 2400 R, right? Multiply by the R. And then on the right-hand side, we have 10 times this stuff. So that's going to add a 0 here. Oops, 25, 0, 0, 0, 0, 0, minus 10R squared. Whew. All right. Well, not too bad because some things are going to work out nicely here. I got minus 2400R plus 2400R. So those kill each other. I've got 12 with 5 zeros, another 12 with 5 zeros. That makes 24 with 5 zeros. Okay, I think it's getting simpler already. Oh, well, look at this. If I add 10R to both sides, 10R squared, rather, and then subtract 24 with 5 zeros after it from both sides, what happens? Well, the 10R squared ends up over here. And these things cancel off over here. And I get 25 with 5 zeros minus 24 with 5 zeros. That's just 1 with 5 zeros. Okay. Divide both sides by 10. Right? So this is an equation we can solve pretty simply. If something squared equals this, that means R must be equal to plus or minus the square root of that. The square root of this, you just cut the number of zeros in half. Excuse me. So that's just plus or minus 100. Okay. It's plus or minus because we didn't indicate whether we were going against the jet stream or with the jet stream. Right? So it could be with us or against us, plus or minus. They just want the speed of the jet stream, so 100. Okay. Speed of the jet stream, the speed of the jet stream was 100 miles per hour.